In an earlier video, I showed how to solve transshipment problems in Excel using this setup. However, this setup does not work with non-standard networks where shipments are allowed between any two nodes, like this network. In a case like this, we can either use the long horizontal format and define a decision variable for each arc, which will require 18 variables in this case, or we can set it up using this origin-destination format, which is more flexible and can be applied to other network problems like transportation, assignment, maximal flow, and shortest route. These are the nodes in the network. Since total supply is greater than total demand, we use less than or equal signs for the supply constraints. All other constraints have equality. Since the warehouses are transshipment nodes, their net supplies are zeros. And the distribution centers have negative signs since they have negative net supplies. The origins are listed in the from column here, and the destinations in the to column. The corresponding unit costs, that is, the objective function coefficients, are in the third column. I'm going to right-click on the C here and insert a column for the units shipped from node to node. I'm going to highlight the cells and shade it yellow. To the right here, we have all the nodes listed. Note that we could have just used the node numbers as seen here instead of using the node names. If you're using the node names, ensure that they are typed exactly the same way in every instance. Next, I'm going to create name references for the 4 columns. Select the 4 columns, click Formulas, then Create from Selection, or use Ctrl-Shift-F3. I'm going to uncheck left column, leave top row checked, and click OK. To the right here, we have all the nodes listed. For the outflow and inflow, I'll be using the SUMIF function to sum or add the units shipped or the flow amounts for each node. For plant 1 outflow, we use equals SUMIF. The range will be all the origins because we're talking about outflows. It shows from here because we named all that column earlier. Otherwise, it will have shown A2 to A19. Comma, in this range, the criteria or what we're looking for is plant 1, which is F2 here. Comma, then the range we want to sum, which is the shipped column. This essentially instructs Excel to look in the from column for plant 1, then sum all entries corresponding to plant 1 in the shipped column. For example, if plant 1 ships 50 units to warehouse 1, then the outflow is 50. If it also ships 40 to warehouse 2, then the outflow becomes 90. And if it also ships 10 to DC1, then the outflow becomes 100. I'm going to delete these entries and enter the SUMIF formula for inflow. The range will be the to or destination column. Comma, we're looking for plant 1 there. Comma, and we want to sum the entries in the shipped column corresponding to plant 1. This cell will eventually return 0 since there is no plant 1 in the to column. For the net flow, we're going to do outflow minus inflow. Then select the formulas and double-click on the fill handle to copy them down. I will double-click on one of the cells to ensure the formula is copied correctly. Note that instead of using column names, if I had used cell ranges like B2 to B19 here, I will have had to make them absolute cells. That is, lock them down before I copy the formulas down from plant 1. Next, for the total cost, we use equals sum product of the unit shipped and the unit cost. I'm going to shade that light green, and I'm going to shade the net flow cells as well. Now we're ready to use Solver. Click the Data tab. Click Solver. If you don't have Solver installed, see description on how to install it. Select Mean since we're minimizing costs. For the objective, select the total cost function. For variable cells, select the unit shipped cells. Next, click Add to add constraints. Select the net flow cells for the plants. Less or equal to their net supplies. Click Add. Since the remaining constraints all have equal signs, I'll select all of them at once. Select the equal sign and their right-hand sides. I'm going to click OK. Ensure that non-negativity box is checked. Select Simplex LP. Click Solve and click OK. So here we have the total cost, the units to ship between the nodes here, and the outflow and inflow for each node here. Now suppose warehouse 1 cannot ship to DC2. Then I can right-click on the row number here and delete it. We can also set the units to 0 without deleting the row. For example, if plant 2 also cannot ship to warehouse 1, we can set the corresponding shipped cell to 0 by going to Solver, click Add, click the cell, and set it equal to 0 on the right side. Click OK. Solve. OK. Now, suppose demand at DC1 changes to 400 so that we have a balanced problem where total demand equals total supply. Then all the constraint signs will be equal signs. Solving that, we can change the supply constraints to equality constraints. Although it won't make any difference to the solution since the model is balanced. Now, suppose we have capacitated routes. For example, suppose we cannot ship more than 600 units from both warehouses. I'm going to insert a column here for the signs. Copy and paste for the rest of the warehouses. Go to Data, Solver, click Add. The cell reference will be the shipped cells, less or equal, and on the right, select the 600s. OK. Solve. OK. And here we have the updated solution. And that's it. Thanks for watching.